Hello, pirates. Today's topic is populations and what are trends and causes of population growth. So we're going to look at a couple different population curves and think about how populations grow and what are some ways that they change. So we're going to start with just what are 4 ways that a population can change in size. And when we think about populations, the population will get bigger or will grow if there is going to be more individuals born. So if we have births or reproduction. The population could change in size when an individual dies. So population growth depends on the number of births, the number of deaths. And then we also have changes in population based on are people coming into the population or leaving the population. So if individuals are coming into a population, we call that immigration. So moving into an area, you are immigrating with an I. So you're coming into the area. And immigration, or immigration with an E, this means that individuals are exiting the area. So they are leaving the population. How we get a growth rate for the population overall is by calculating the number of births and individuals moving into an area by the number of individuals that are dying or leaving an area. And that will give us a growth rate. If the number is positive, so if we get a positive number, that means that there are more births than deaths. And if there are more births than deaths, then that means that the population is growing. Okay, so more births and people moving in than individuals dying or leaving, you're going to have an increase in your population. If the number is negative, that means there is more deaths or more individuals leaving an area, and in that case, the population will decline. All right, so there's 2 different curves when we look at a population, so 2 ways that they grow, and we focus on the J curve and the S curve. Starting with the J curve, you want to imagine a population, and in that population, imagine that the population is doubling maybe every 30 minutes if it's a population of bacteria. So we start off with 1 bacteria. 30 minutes later, it divides, there's 2. Another 30 minutes, there's 4. 4 goes to 8. 8 goes to 16, and so on. So in this kind of population, a J curve happens exponentially. So the population starts off slow and then it grows really rapidly, and it looks like the letter J. So a J curve is exponential growth. So things are growing exponentially, and the population growth starts out slow and then it becomes very rapid. So slow to rapid growth. In this type of curve, we have unlimited resources. So this is the land of plenty. So resources are unlimited, and there are no predators. So there's nothing that's going to kill you as an individual organism, or you live out your normal life. An example of something that reproduces and grows this way is invasive species. Okay, so invasive species, they typically will start off with exponential growth. Okay. All right, the next curve is when you think about a population, though, at some point there is a limit on resources. So whether you live on an island or a continent, eventually you're going to run out of the land of plenty. The plenty isn't going to be available forever. So this type of growth is called logistic, and this looks like the letter S. So this is a logistic growth. And with logistic growth, the population is going to start out rapidly. So we're going to start with rapid growth, and then it's going to level off. So the population levels off. So here's my population, and the population is going to start by growing quickly like the J curve, and then it's going to hit a limit on resources, and then it's going to come back down. So this is going to look here like the letter S, and then it might rebound again. All right, and it might go down again. So we start with rapid growth, and then we have a leveling off. In this scenario, there is a limit on resources. So the resources are not infinite, and predators are present. Examples, the things that go this way are going to be things like native populations in an area are going to have a limit, and they're going to have predators. So native populations, meaning species that live in an area and have, I don't know, we'll look at a deer population here soon, or rabbits and like wolves and things, or bacteria in a petri dish. All right, so when this population hits a limit, we call that its carrying capacity. And so for the carrying capacity, we look at where the population oscillates. So we kind of look from here to here, and we draw a line right in the center of that. And that would be the carrying capacity. So you can see the population kind of overshoots its carrying capacity, and then it dips below its carrying capacity, and it overshoots it, and then it'll dip back below. So we have referred to this as a carrying capacity, which sometimes is represented at the top with the letter K. And what a carrying capacity is the carrying capacity is the maximum number of individuals that the population can support. So this is the maximum number of individuals supported by the environment. What you guys need to do then is I want you guys to watch a couple of videos about population, because we want to focus on our own population, human population. And what you guys want to think about is our population growth for humans? Can we grow on exponentially? Do we have any limit on our resources, or are we clever enough to kind of elude that? So what you guys want to do is watch those videos, answer these questions on the side, 1, 2, 3, okay? Down here in your summary, and then you guys want to watch the human population videos and answer the human population worksheets, and then submit that. The human population worksheet is going on page 140. Let me know if you have any questions. Have a wonderful day.